Hello everyone and welcome back. Today I'm gonna talk about the word analog. In everyday life, we use this word quite often. For example, you see a dog. Well, dogs have also noses. Well, we also have noses as human beings. So those two entities resemble each other and we say that they are two analogous organs. But in physics, we use this word in a more sophisticated setting because we are trying to explain something that is abstract, that is a model, that is not something that you can observe. Because physical theories are just abstractions, and what you observe in reality are just the manifestation of those abstractions. So what I'm trying to say is that people in physics use the word analog to objects or to models that resemble each other. But the problem I observe with the word analogous is that it is quite vague. By vague, I mean people use this word quite often and they overkill the meaning of this word. For example, in quantum mechanics, instead of saying that wave interpretation and particle interpretation are dual each other, like Heisenberg's picture and Schrödinger's picture, that's another point of view. There are two ways of looking at the same phenomena. One is a matrix interpretation, the other one is wave interpretation of quantum mechanics. But they're not you can't use the word analog for that because, you see, for example, for particle wave equivalence, we use the word duality. And duality means, at least in this setting, is the two sides of the same entity, two sides of the same coin, let's say. So we know exactly by what we mean by dual. They need to, under some, let's say, transformation, under some rules, they need to give exactly the same answer. But when we say the word analog, we don't expect the two systems to give the same answer. For example, you can map Einstein's field equations in a refractive media. You don't exactly expect that the two models give you the same answer, but what you expect is that, for example, the horizon structure of a black hole is mapped into such a system, such a setting, that you can observe something that resembles Hawking radiation in an optical media. And that is the strength of the optical settings. That's why people are trying to create some optical phenomena in a laboratory that can resemble a black hole horizon, because you can't just see a black hole on Earth. We can't create a black hole on Earth yet. We have the physics, but we can't just engineer it yet. But what I'm trying to say is that you don't actually obtain, for example, if we have recreated the physics of a black hole on Earth, it will destroy the Earth. But what we are trying to do is that we are trying to resemble a structure, that is a horizon of a black hole, on a similar model, on a similar physics that can resemble that. For example, as I said, an optical media. So that is what we mean by analogous structure. We are not saying that we can recreate that exact phenomena under a different setting. No, that's not what analogous means. But this definition is quite vague. And when people study physics, they study physics often while studying mathematics. And in mathematics, the word analog is more, let's say, rigorous. But you see, mathematics has different settings. So they have different branches, algebra, topology, and so on and forth. It goes and goes and goes. And more often than not, they are distinct structures from each other. They have different axioms, meaning that the word analog mean different. They have different definitions in different fields in mathematics. So, in physics, which is a, let's say, less sophisticated science than mathematics, we use the word analog so quite often, but we use it so vague. What do we mean by, let's say, the word analog? For example, let's give another example to exemplify this vagueness. As I said to you, you can map a black hole horizon to an optical media, but you can also map a black hole horizon to a Bose-Einstein condensate. That's also an analogous structure. But how should we compare those two analogous structures? Should we say that one is more analogous than the other? Well, maybe we should. Maybe we should be able to quantify, maybe we should be able to quantify the degree of the analogousness of that system to another system. So it's like a correlation function. You have your range, you have your domain, and it goes to a range. And if that correlation between two different models in physics are, let's say, are trivial, if those connections are trivial, then what you have is a dual connection. Because as I explained to you, what dual means is that they are basically the two entities. They are explanations of the same entity. So they are two sides of the same coin. And if that connection is trivial, this is exactly what we mean by being dual. And if there is a one-to-one mapping between different theories, then it should be a strong correlation between two different models of physics. So this should be a criteria for defining this new definition. So I believe that we need to make a more rigorous, let's say, approach to the word dual and the word analog in physics. And this kind of approach might be a good way to go. So thank you and stay with physics.